An alien comet, only the third we have ever detected, is not just skimming past Mars right now. It's arriving. This is no longer a prediction, it's a reality. The object known as 3I/ATLAS is approaching fast, sweeping through the inner solar system with its coma expanding and its tail stretching in ways we're still trying to understand. It will pass closer than any interstellar object has ever come to one of our planetary neighbors. And yet, in the face of this extraordinary, once-in-a-lifetime encounter, NASA remains almost completely silent. This video is sponsored by Upstream. Want to grow your YouTube channel faster? With Upstream, you can run a 24/7 live stream using your pre-recorded videos. Since live streams rank higher in search, you'll gain more views, more subscribers, and more revenue. And it's not just YouTube. Upstream lets you multi-stream to up to 10 platforms, design custom layouts that match your brand, and schedule your content so your channel is live even when you're not. Sign up free today with the link in the description. And if you decide to upgrade, you'll get 20% off your first month. Start streaming smarter with Upstream. Europe's orbiters are watching it in real time, logging high-resolution images and spectra, but NASA's feeds are strangely quiet. We're hearing only scattered technical updates buried in obscure archives, quietly confirming the trajectory, but not the implications, not the questions. If this is such an unprecedented visit, why aren't we hearing the usual fanfare? What could NASA's instruments already know that we don't? What could they be seeing that they're not telling us? This is not just another object. From the moment it crossed the orbit of Jupiter, 3I/ATLAS began to behave in ways that challenge what we expect from natural interstellar debris. It flared to life earlier than it should have. Its path through the solar system feels almost deliberate, like the footprint of something that knows exactly where it's going. And now, with Mars just ahead, we're watching from Earth as our best planetary probes prepare to study it. Orbiters around the red planet are aiming their spectrometers and cameras. The James Webb Space Telescope is locked on its spectral trail. Hubble is tracking its coma. And still, why is NASA silent now? When something from another star is flying this close to home, the silence is louder than ever. Comet 3I/ATLAS, a cosmic wanderer, was first spotted on July 1, 2025, by the NASA-funded ATLAS telescope in Chile. But here's the thing, within hours, astronomers realized its path was too fast, too steep, too unnatural to be bound to our sun. Its orbit is hyperbolic, a definitive one-way ticket from the depths of interstellar space, just passing through and then back out again. This singular characteristic makes it only the third confirmed interstellar object we've ever seen, after the enigmatic Oumuamua in 2017 and the Comet 2I/Borisov in 2019. By October 2025, right now, its nucleus is sweeping within a mere 30 million kilometers of Mars. Think about that proximity. It's close enough for our fleet-footed spacecraft to literally taste its gases and dust, to analyze its very essence, and Europe is seizing this moment. ESA's Mars Express and the Trace Gas Orbiter began their dedicated observation campaign on October 1st, logging high-resolution images and spectra. They'll continue through October 7th. Even the JUICE spacecraft, already en route to Jupiter, will swing its cameras around in November to catch a glimpse. These instruments are not hunting for beauty, they're searching for anomalies. Calmer, but NASA, the agency with the most eyes and ears on Mars, has stuck to routine mission updates and a brief JPL blog post that reads more like a footnote. A quiet acknowledgement, rather than the screaming headline this unprecedented event deserves. the silence is louder than ever. As 3I/ATLAS draws closer to Mars, its trajectory no longer raises questions of origin, but of intent. It is not just passing through, it is aligning. This object, older than any planet it now drifts past, is threading a path that would seem improbable, even for a spacecraft guided by human precision. A near-linear sequence across the solar system, each flyby timed with surgical elegance. For something supposedly born of chaos, its movement feels unnervingly calculated, and yet there is no public briefing, no global countdown. The only voices acknowledging its approach are fragmented, scattered among observatories, mission briefings, and anonymous academic forums. Space fans, the truly engaged ones, notice when the usual briefing slows to a trickle. We see the Perseverance rover tweeting its rock selfies daily. We watch the Parker Solar Probe team celebrate every single perihelion with a flourish. Yet on 3I/ATLAS, we get radio static. It's a stark, jarring contrast. Officially, NASA says nothing is hidden. They tell us the object was discovered by an external survey, the initial alerts coming from the University of Hawaii's Atlas team, then ESA, and finally, the Minor Planet Center. NASA headquarters reminds us, with a polite and almost bureaucratic tone, that public affairs officers must coordinate with multiple science groups before releasing any splashy graphics or making grand pronouncements. That chain of command, they explain, can take weeks, especially when no NASA spacecraft is the designated primary observer. And yes, we understand process, we understand bureaucracy. But still, the contrast is jarring, almost deafening. ESA live tweets Spectra offering raw data and immediate insights, while NASA's Mars fleet, with all its incredible capabilities, stays politely in the background, almost apologetically quiet. This isn't just about a delay, it's about a fundamental difference in approach. Some data has leaked into preprints, images from Mars orbiters, infrared traces from James Webb, and a recent spike in CO2 emissions around the Comet. But there is no narrative to tie them together. No explanation offered by the very institutions whose purpose is to help us understand the unknown. It leaves us wondering, if the data is out there, why isn't their voice leading the conversation? Why is the official narrative missing? So, what is Europe actually seeing? From their perch, riding the Martian magnetosphere like surfers on a quiet swell, ESA's orbiters are watching the comet's bright aqua coma bloom across their cameras. Their spectrometers are sniffing out intriguing compounds: carbonyl sulfide, formaldehyde, and, most curiously, an odd ratio of carbon-13 to carbon-12 that definitively does not match typical solar system comets. This isn't just a slight deviation. It's a fundamental chemical signature that screams other. The tail itself is a spectacle, showing filaments that twist every 7.44 hours, a peculiar rhythm that hints at a nucleus wobbling, perhaps tumbling like a badly thrown football. And it's not just visual. Dust impacts are registering on the spacecraft's star trackers as microscopic flashes, tiny echoes of the comet's journey. Here's the critical part. None of this is classified. The raw data, the very stuff of scientific discovery, appears on ESA's raw data portal within 48 hours. While NASA remains tight-lipped, scientists on Twitter are already openly arguing, speculating, and debating whether the ratio of gaseous nickel to carbon, for instance, could only form in the outermost layers of another star's Kuiper belt. This conversation is open, it's loud, It's vibrant, and it's exactly the kind of immediate scientific engagement that we are missing from NASA's channels. The Mars Express and Trace Gas Orbiter have adjusted their observation schedules. Their spectrometers are being tuned to pick up water ice, organics, and unusual isotopic ratios. These instruments are not hunting for beauty. They are searching for anomalies. The Comet is not behaving like those of ordinary comets. Some of its particles are denser, slower to disperse. The tail, under certain observations, appears angled toward the sun, as if repelled not by radiation, but by something else, something we have yet to quantify. This is not speculation. This is data, and data does not lie. Now, let's look at NASA's side of the desk. They do have 3 incredibly capable orbiters at Mars: MAVEN, the Mars Reconnaissance Orbiter, and the newly arrived ESC-APADE twin probes. Each of these carries instruments perfectly capable of ultraviolet spectroscopy, high-resolution imaging, or energetic particle detection. And to be fair, they are doing something. According to their own mission pages, if you dig deep enough, MAVEN's imaging ultraviolet spectrograph collected several hours of comet data on October 3rd. The Mars Reconnaissance Orbiter even rolled to a 30-degree off-nadir angle to photograph the Comet against the Martian night-side air. These actions clearly show the agency isn't entirely ignoring this extraordinary visitor. It's just not publicizing its preliminary results. Their official line is that NASA policy encourages teams to submit findings to peer-reviewed journals before holding press conferences or releasing splashy public statements. That Casio once gave us the breathtaking Pluto flyby images, but only after a 5-month wait, and that was for an object within our solar system. The fundamental difference now, the critical point we seem to be missing, is that an interstellar comet like 3I/ATLAS will not wait for a publication cycle. It leaves the inner solar system for good by early 2026. This isn't a long-term resident. It's a fleeting ghost, a cosmic whisper. If we wait for peer review, the public moment, will be gone. The data will still be valuable, yes, immensely so, but the shared experience, the collective awe, will have vanished with the comet itself. So, is this a conspiracy, or just plain old bureaucracy? Headlines, of course, love a good cover-up narrative, but as we often find, the mundane answer is usually just process. NASA's Science Mission Directorate routes every single comet update through the Planetary Defense Coordination Office, and if an object poses no immediate impact threat to Earth, and 3I/ATLAS never comes closer than 1.4 astronomical units to us, the file simply drops several critical rungs on the urgency ladder. It becomes less critical, less immediate. Add to that the government's current operating budget, stuck under a continuing resolution that restricts overtime for public affairs staff, and you get a silence that feels profoundly spooky, even deliberate, but is mostly just paperwork and institutional inertia. But here's the problem. This vacuum of information, this official silence, doesn't just sit there. It actively invites speculation. It fuels the rumor mill. Some amateur observers watching intently claim the comet's brightness fluctuates in a way that suggests artificial reflectors, deliberate signaling. Professional astronomers naturally counter that a tumbling, outgassing nucleus can naturally produce similar light curves. And they're probably right, but without NASA's raw frames, without their immediate, near real-time data released to the public, the rumor mill keeps grinding. The whispers grow louder. The silence itself becomes the signal. An absence of information that allows the most improbable theories to take root. This isn't just a comet being a comet. It's a story being told in fragments, and the official storyteller is conspicuously absent. So why does Mars matter so much for this flyby? Mars sits near the edge of our solar system's snowline, that crucial boundary where water ice can survive long stretches in direct sunlight. When three I/ATLAS crossed this invisible border in September, its pristine interstellar ices began sublimating in earnest, releasing a cloud of vapor that drifts across space like cosmic breath on a cold morning. And because Mars has such a thin atmosphere and a negligible magnetic field, the interaction between cometary ions and the planet's tenuous exosphere is a scientific goldmine. It's simple enough to model, yet complex enough to reveal entirely new physics. We're talking about fundamental interactions here. ESA's Trace Gas Orbiter already measured a temporary uptick in atmospheric magnesium when the planet passed through the comet's tail. Imagine what MAVEN's data could show. It could reveal precisely how those metals ionize in the upper atmosphere, a process incredibly relevant to future terraforming studies and even to understanding Earth's own early history when our planet was bombarded by similar visitors. This isn't just academic curiosity. This is foundational science. That immense, undeniable scientific value makes the persistent lack of NASA press kits, the absence of public excitement, even more puzzling. It's almost as if they're deliberately downplaying something truly profound. What happens next? The clock is ticking. On October 30th, the comet reaches its perihelion, its closest point to the Sun, still inside Mars's orbit, before rocketing upward and out of the ecliptic plane for good. This is the moment of maximum activity, maximum drama. JUICE will photograph it under excellent phase angle conditions in mid-November, potentially catching a tail more than 2 degrees long. A truly spectacular sight. And back on Earth, the James Webb Space Telescope has a short, precious window in December when the target's motion against background stars is slow enough for deep spectroscopy, allowing us to peer into its very chemical heart. But if NASA's current policy holds, if the bureaucracy continues to win, we may not hear any coordinated, publicly released results until a special session of the Lunar and Planetary Science Conference next March. By then, 3I/ATLAS will be far beyond Jupiter's orbit. Fade in. Dream. The data itself will still be valuable, yes, immensely so. But the public moment, the shared experience of witnessing something truly alien, will have passed. We will have missed the live performance, only to be handed a delayed review months later. It's a tragic loss of collective wonder. If you want to keep track of real-time updates faster than official press offices ever move, then you already know the drill. Check the links in the description. We've got live data feeds, mission Twitter lists, and the latest preprints. The unfiltered truth, direct from the source. Smash that subscribe button if you like your space news raw, unfiltered, and with a healthy dose of skepticism. Drop your own theories below, because the best conversations often happen right here. And please, share this video with anyone who still thinks NASA tweets everything it knows. Poor interstellar objects are more than just rocks. They are cosmic postcards from unknown neighborhoods, fleeting glimpses of other star systems. 3I/ATLAS is our third letter, and for once, the envelope is addressed directly to Mars. Europe's postmen are shouting the headlines from the rooftops, live tweeting spectra and raw data, while NASA's are quietly filing the envelope away for later, perhaps for a press conference next March. Bureaucracy or conspiracy, the result is the same. The universe handed humanity a front-row ticket to an alien show, a truly unprecedented spectacle, and most of the audience is stuck waiting for the review instead of watching the performance live. This is not a comet. This is a signal, and the ones with the most answers are saying the least. Keep looking up, keep asking who gets to write the first draft of history. And remember, often, the silence itself is the most profound part of the story. It's a deliberate absence, a pause placed where a message should be. And if this object truly is what they say it is, just another rock, just another relic, then why does it feel like it's watching us?